Hey everyone, I'm joined by Scott Wasson talking about frame rate and frame times and how they are flawed to go by just the normal frame rate metrics that we all see, that we use, everyone else uses pretty much. So we're bringing it back to frame times. You did inside the second, right?
Yeah.
And that was a pretty big piece that talked about all the problems with frame rate as a number. And what was your alternative to frame rate?
And so it was really looking at, as you mentioned, frame times instead of rates. And there are a number of reasons for that. One of the key ones is just that we were always looking at frame rate as an average. And it turns out that averages can mask big differences that matter to you as you play a game, because if you have momentary hiccups in your game, you're going to notice it, the animation's not going to be smooth, and it's terrible.
Yeah, it's a huge problem. It's one we've talked about recently with our frame time plots, and we're going to be talking about that more today. Before that, this video is brought to you by the Thermaltake M360 Plus Liquid Cooling Kit, which comes with everything needed for your first open-loop cooling solution. The M360 Plus LC kit includes a pump and reservoir combo, a CPU water block, 360 radiator, coolant, plenty of tubing, and RGB everything. If you're looking for a one-stop shop for a first-time open loop, the M360 Plus is linked in the description below. So the big topic here is, this discussion started from FPS as non-linear. And here's the secret that some of you might not be aware of if you haven't seen our previous video together. So the secret is all the FPS data is flawed, and you can only trust it so much. But we're going to give it to you anyway. But frame times, that matters. So let's do a masterclass overview. What is a frame time? What is it measuring?
Right, so typically when we talk about frame time, we're talking about the interval from one frame to the next frame, right? When you're building an animation, you want to make sure that you have a pretty constant flow of updates to the display, updates to the user so that the animation looks smooth. And when that's interrupted, then you perceive it as stutter and slowdowns and things like that, and that's what you want to avoid. So if you can look at individual frame times and find metrics that account for those hiccups and slowdowns, it's a little bit better than looking at an average where you can have a lot of fast frames and one very slow frame in the middle. It's a bad experience, but the average will hide that and will mask that.
And we'll put a chart on the screen. We had a Far Cry 5 test recently where just one product against itself. So in this instance, it was a 9600K. And the reason it was interesting is because the average frame rate looked pretty good. It's completely playable. I don't remember, it's 100 or something. Then the lows even were still like 60 FPS for our 0.1% low metric, which in that video we said, well, there's a reason that we sometimes show a frame time plot instead, because this is actually flawed. Because by that metric, by our own metric, 0.1%, you're looking at 60 FPS, which seems perfectly fine. You look at the frame time plot and you have 3 or 4 spikes to 100 milliseconds. And so to explain what that means, I guess let's pull some numbers. So you have 60 FPS. What kind of frame-to-frame interval are you looking at?
16.7 milliseconds.
Right.
Yeah.
So let's pull some others, I guess. So you look at maybe like 120, 140, you're at 7 or 8 milliseconds.
Exactly.
And what does that time mean? 16.667 milliseconds to do what?
Right, from one frame to the next on the display. Depending on, of course, there's also the interaction with the display's update rate and that timing.
Right.
But if you have a fast display or especially a variable refresh display like FreeSync, then really it comes down more or less to the GPU frame time, right? So the less time between frames, the smoother the animation. And I've talked about this before because you see people online saying 60 FPS is all the human eye can perceive or whatever. Get yourself a 144 hertz monitor. Go to the Windows desktop, drag a window around with your mouse, and you can easily perceive the difference between 60 and 144.
Yes.
I have 144 hertz displays around me, and when I have to use a 61, it annoys me to copy files. Okay, there is clearly a difference that you can perceive.
Yeah, and that's just Windows.
Right.
It's not even games.
Right.
Right. So the time then, the frame-to-frame interval you're looking at, time between frames or time to create the next frame, I guess. At what point really is it the consistency of that number that users notice, or is it just lower is always better? I mean, if you're at 4 milliseconds constantly, where do you draw the line of that being a good experience versus a bad experience because of spikes?
Right. That's a tough one because it's about human perception, but it's also about a lot of the stuff that happens in the PC that's a little bit sloppy. The interaction between the game engine and when physics animation, the game engine advances, the GPU and the whole system when it flips frames, and then the display when it's ready to actually show you frames. There's a lot of timing issues there that don't always get resolved well. But in a case of a game engine that does a good job and a fast system, and then say a variable refresh display that sort of tries to match the timing of when a frame is ready, will show it. Then you have the question of what happens in my headspace. And it's not, you can't say the human brain runs at 144 hertz. Like, it's this analog meat space thing.
I've seen YouTube thumbnails that say that.
Yeah, well, I'm sorry. This analog meat space thing that I don't think we know exactly.
Right.
But if you look at all the animation systems that we have, none of them go, like, I think the slowest we know of is movies. And it's 24 frames per second. And usually in movies, each exposure is sort of window of time instead of a quick slice. They actually leave the camera aperture open for a while as they capture each frame. There's some blur, right? Even then, 24 is not always great, right? And that's sort of their frame rate. So perceptually speaking, I think if you get below that, you get around 20 frames per second, about 50 milliseconds. I think that's where you start saying we're at a perceptual threshold where there's a problem. Right. But then there are also all these questions about frame rates varying over time, different people noticing different things. It's complicated. And I don't think we have at least I haven't seen good science behind all of that to know, a definitive answer to the meat space question.
Right, yeah.
Right?
And a lot of people try to do that, but yeah, I have not seen any hard science to it other than like Watch Mojo top 10 things you didn't know about the human brain or something. So for the FPS is non-linear discussion point. That's something you put a tweet out recently. We'll put that up on the screen too with a graph.
Yeah.
What does that mean? What am I looking at?
Yeah, so if you look at the graph, it shows basically frame time versus FPS over time. And it just turns out that FPS, because it's a rate, it's not a linear measure of performance. So I guess the best way to illustrate this is like we were talking about before. At 60 frames per second, the frame times are 16.7 milliseconds. You get to 144, it's like 7 milliseconds. And the problem is that, and at 30 frames per second, it's 33 milliseconds. Right. So you're not getting, the difference in FPS will actually be larger, especially at high frame rates, than the difference in frame times. You actually have this funny curve, right? And that leads to sometimes some not very good online discussions, maybe in the forum or comments, about the differences between different performances. And I think the classic best example of this is when you're talking about game performance over 200 frames per second.
Yes.
Right? If you have something at 230 frames per second, and you have another device that runs this game at 200 frames per second, people say, well, that's a 30 FPS difference, that's huge. And a gamer will know that in certain cases, 30 FPS is a very large difference, perceptually speaking.
In certain cases.
But the case that the gamer may be thinking about is the difference between 30 frames per second and 60 frames per second, which it turns out, because FPS is not linear, is a much larger difference than the difference between 200 and 230 frames per second.
Right.
And so
you're functionally having your frame-to-frame interval, whereas you start going up to like 300 FPS versus 270 FPS, rough math, but I think you're at about a 0.5 millisecond difference between in terms of the frame, the time it takes to create that frame, 0.5 milliseconds longer to create the frame at 270 FPS versus 300 FPS. So if we're talking 3.0 or 3.5 versus 3.5 or 4.0, really, who notices that, I guess, is the question.
Right. Well, that's the thing, is you start getting into very high frame rates, FPS differences that sound consequential, but turn out to be very small differences in time if you measure it in frame times by milliseconds, which is a linear measurement. Right. And so I think you get to the point where you're kind of overvaluing or exaggerating those differences at high FPS compared to low.
So then what if we, let's approach this from how a lot of reviewers will do it, including us sometimes. What if you convert that into a percentage? So now it's not FPS. So it's you're not worrying about the nonlinear side of a raw number of FPS. Still nonlinear because it's a percentage of a nonlinear number.
Right.
But if you're talking 60 FPS versus 54 FPS, depending if you're doing percent improvement or percent reduction, is roughly 10% difference. And then you have 200 versus 220. It's roughly a 10% difference as well.
Right.
So is that an acceptable approach in your mind?
Well, you have an underlying metric that's not linear.
Right.
And so you're going to retain that non-linearity.
Yes.
And so you're going to have the same basic problem. It maybe is worse because you've masked what you just did there.
Yeah.
You know, if you don't have your units, if it's just a
Right.
percentage. I think that the appropriate way, if you had to do percentages, and there are problems with doing percentages beyond this, but the appropriate way if you had
Like
to do
just stat math in general
right.
is misleading. Yeah.
But if you have to use a percentage or you decide that's what you want to do, then I'd say start with the base unit of frame times and do a percentage in frame times instead of in FPS,
Right.
so that you have a sort of honest accounting of the difference. Now that would mean, you know, in one of our example cases like the 307 versus 270.
Yes.
You know,
We can do some
it's
math
like
on this
it's like
too.
a half millisecond difference, right?
Yeah, so if you take, let's say 300 FPS is 3.3 milliseconds it's just 1,000 divided by the frame rate. So 3.3 milliseconds versus, what do you want to say, 270, 250?
270.
270 is 3.7. So the percent improvement of new minus old divided by old, 300 minus 270 equals 30 divided by 270. Percent improvement is 11% if you go that direction, based on frame rate. Whereas what were our numbers? 3.3 versus 3.7, I think. 3. New would be down in this case, so 3.3 minus 3.7 divided by 3.7. You've got roughly an 11% reduction, but we just went two different directions with the percentage math, right? Because if you're doing new minus old divided by old, and your new number is now lower instead of higher, that's going to change the math too. So percentages in general,
yeah, well,
kind of
they
misleading, right?
obscure things, right?
Yes.
And one of the things I was going to say is when you're talking about a half millisecond difference.
And if we go the other way, 12% by the way.
Okay.
But continue.
Right. If you're talking about a half millisecond difference in the performance of two systems, then you can ask yourself the question: is this meaningful? Right? You know, is the display capable of showing me a half millisecond difference? Am I capable of perceiving it? Right? Whereas if you're talking about a difference that's, you know, 10, 15, 16 milliseconds, then that may be a very different conversation.
Right.
Right? And so percentages can mask the native units, and so you're not thinking about the perceptual element in the same way as you would be if you were thinking about the native units.
Yes, right.
Yeah.
And then let me channel my inner Gordon from PC World. Some of you may have seen that video where I was with him. Gordon had a great phrase, I thought. He said, but I'm the internet though, but I'm the internet. So Scott, if I'm the internet, 240 FPS, 300 FPS, I can see that difference. I can see 300 FPS, so you are wrong. How do you respond to that?
Well, that's an interesting one because are there very many displays that are faster than 240 hertz refresh rate?
Well, if I'm the internet, I'm going to say yes without checking.
right. I think the answer is that there aren't many,
I don't think so.
right? And then we can talk about that in that case, again, we're talking what about 0.7 millisecond difference or something if I'm estimating off the top of my head, you know? And we just had this conversation about the meat space situation, you know, where, you know, we really notice a problem in animation above like 50 or so milliseconds. I mean, you're at the outer end of the human scale, right?
Yeah.
Plus then, there's some slop between the game engine's timing and when things get sent to the display and when the display finally gets the pixels updated, you know, that can be more than that 0.7 millisecond delta.
Sure.
So the timing on all this stuff is hard, right? And so I suppose it's difficult at the end of the day to dissuade someone who's completely confident that they're correct. But there really are like numbers and perceptual thresholds and realities of other variables in here that pretty much will tell you, you know, no, you're not you're not going to see that.
Right, right. And FPS in general, I should also say, is just kind of a funny number to begin with. Because if it's frames per second, but you're looking at the active, like an FPS counter on the screen, you kind of get into a territory of what does that really mean? Because if I'm playing the game and I'm looking at a counter of 60 FPS, is that referencing the previous second averaged of frame time? And I guess that kind of depends on the software and how it measures too. Why don't we all just use frame times? I guess would be the reasonable question someone might ask after hearing all of this.
Right.
I think from my perspective, there are two answers. And one is everybody understands it, even if it doesn't necessarily mean, if it's not a perfect metric, they understand it or think they understand it. The other one is from a presentation side, it's easier to present a bunch of bar graphs. Because if you do an over time plot, like some of the ones we've shown, you really can't get more than a couple lines before it's just illegible.
Right.
So how do you compromise? How do you compromise between a metric that is objectively better to use, frame to frame interval, frame times, versus a metric that is widely understood by the audience?
Right.
So is that just an education problem of teaching the viewer?
Yeah, I think to some extent it is, but to some extent you've got to try to meet the viewer halfway, right? So here's one of the conversations that we've always had about this is, I like the idea of using a frame time, and I actually like the idea of using a 99th percentile frame time where you have this curve, because this is the problem, you have a distribution of frame times, it's not just one, and you have to summarize this entire collection in some meaningful way, and so you can sort of sort them smaller to higher. So you can pick a point on that curve, and you can say, okay, this is where we are at 99% of all frames rendered, this is the time that we have, and you can compare that across lots of different things, right? And that works. Then the conversation becomes, well, why are we using frame time if everybody's used to FPS? Can we do the 99th percentile FPS? And the answer is sure, you can. But realize that when you do that, you're compromising the native units and you're going to a non-linear measurement.
And it still averages out some of the frame time spikes too. Even at 0.1%, you average a lot of those out.
Oh, well, now that's a different thing, right?
Yeah.
When you're doing 0.1 or 0.01%, and I didn't know this until we had a conversation about it fairly recently, but 0.1% is basically the last 0.1% of frames that distribution collected together and then averaged.
Yeah.
And when you average, then you can mask problems.
Yeah.
Right?
And that's why it's important if you use those numbers. So again, our 9600K review is the most recent that I can reference. If you use those numbers, you're either referring to them as a viewer or you're using them as a reviewer. You have to understand the whole picture of the data and what might be hidden by an average. So it's still important to go look at a frame time plot, look at where does it spike. Then you look at your averaged numbers and does it hide all of that data. And in the case of Far Cry 5, it did, going back to our earlier example.
Right.
Far Cry 5 was objectively a bad experience because you would hit these stutters that are 1/10 of a second long.
It's too long.
Which is bad, yeah. But you don't see it in a 0.1% because it averages it out even though it's only 0.1%.
Yeah.
So yeah, it's still flawed.
Yeah. So it's always a challenge because you want to do the right thing in terms of the metrics, but you want people to be able to understand and consume what you're doing, right? And I haven't found a perfect answer yet. There's some approaches like the percentile thing or time spent beyond X that we could talk about that are, I think, reasonably good metrics of certain things. But yeah, it's hard to sort of summarize. And in an ideal world, when things go well, maybe FPS would be enough, right? That's at least the potential that the graphics card and the system has to produce performance. The question is, does it deliver it consistently? And that's another question.
Right. Yes, and then you've got the old questions of frame quality too. Like if the different graphics devices render the frame a different way, different color space, whatever, which is something you probably dealt with more when you were doing tech report maybe 10 years ago or something, where the frame quality was, because I remember there used to be like a Firestrike test where you could pull like a single frame render and then compare the frames side by side on ATI at the time and NVIDIA.
Right, well, it's interesting because graphics APIs are not compute APIs. And a CPU, if you compute a number and you get the wrong answer, it's bad, right? Things will crash, it doesn't work, right? And a graphics API, if you compute a color and you output it differently than maybe someone else would, that's not necessarily
Right, it becomes
a problem.
sort of subjective.
Right.
Yeah.
So different GPUs have different texture filtering algorithms that they use and things like that. So there's not a deterministic, this color of this pixel should be exactly this value, right? And so everybody in graphics, whether it's the game developer or the driver writer or the GPU architect, is trying to do their best job of combining sort of faking, this needs to look good, but we don't want to do too much work. Combining those two elements in order to give you a good experience. And yeah, it can get tricky. Yeah.
Yes. So I would say if you want more of this discussion, go to Tech Report and read Scott's articles. But you might have already read them. If not, check out, what is it called?
Inside the Second.
Inside the Second from a couple years ago at this point. That's a good starter. And I think we talked previously, I think there was one thing you might have changed about that article if you wrote it today. The phrasing of, was it latency, frame latency?
Yeah.
So why would you change that today?
Okay, so latency or lag is something that we know in computers and gaming and things like that. And I talked a lot about frame latency when I was doing some of these metrics, when it really was about the frame-to-frame interval. And the problem then is that I went to AMD and we started thinking more about how can we reduce input lag. And we actually made some changes in like Radeon software to reduce buffering in some cases so that we have less input lag. Radeon Chill reduces input lag. That's really sort of latency. The key with the animation is the frame-to-frame interval time, which is a bit of a different thing. So I probably would not use...
Change the verbiage.
Yeah, not use that at this point.
But understanding that, check out the article if you haven't. Otherwise, Scott is here with an announcement that we'll talk about later. So stay tuned for more of that. And Scott, thank you for joining me.
Certainly, anytime.
We'll see you all next time.